Section 5.5, Solving Rational Equations. A rational or fractional equation is an equation containing one or more rational expressions. To solve a rational equation, first clear the fractions. We don't like fractions? Get rid of them. Multiply all terms on both sides of the equation by the least common multiple of all the denominators. Then carry out the equation solving process. So we want to get rid of the fractions. So we want to multiply both sides of this equation by a number that guarantees that all of these denominators will cancel. That's the least common denominator, or the least common multiple of these fractions. So we have 3, 8, and 6. So our least common multiple needs a factor of 3 from the 3. It needs 2 to the third from the 8, and it needs a 2, it's got a 2, it needs a 3, it's got a 3, so 6 is in there. So our least common multiple is 8 times 3, 24. A lot of times with numbers you can just know, but our procedure of prime factorization and picking out as many factors as we need always works. So 24 is like our magic number. If we multiply both sides of this equation by 24, we are guaranteed that all of the denominators will cancel. We have to use the distributive property on the left-hand side. And we have 5, 6 times 24 on the right. Now look at how this works. Our first fraction, it's like 24 over 1 times 2 over 3, and we can cancel anything anywhere in the denominator with anything anywhere in the numerator. So 3 goes into 24 8 times. Of course 3 goes into 24 an even number of times, because 24 is the least common multiple of all of these numbers. So that changes that first term to 16. Wonderful. 8 goes into 24 3 times, so it's minus 3x equals 6 goes into 24 4 times, so it's 20. Let us take a moment to admire the beauty of this problem now. 16 minus 3x equals 20. So easy to solve. Think back to our original problem, 2 over 3 minus x over 8 equals 5/6. Totally obnoxious problem. So being able to clear the fractions is a wonderful, wonderful thing to do. All right, so we need to solve this. Let's subtract 16 from both sides, and we get 4. Let's divide both sides by a negative 3, and we get x equals negative 4/3. Okay, that is our solution. You may substitute that back into the original equation and see that it is a solution. It makes a true statement in the original equation. Let's look at this one. What is the least common multiple of 4 and 6? Can you just identify it? Is it 12? I think it is 12. And 12 is 2 times 2 times 3, so it contains the 4 and it contains the 6. Let's multiply both sides of the equation by 12. We have to use the distributive property on the left, so it's 12 times x plus 3 over 4 plus 12 times x plus 2 over 6, and 48 on the left. So 4 goes into 12 3 times, 6 goes into 12 2 times. So using distributive property, we have 3x plus 9, 2x plus 4, 48. Once again, we take a problem that was originally kind of hideous and multiply by the least common multiple of all the denominators. That clears the fractions, and we end up with a lovely problem. Simplify the left-hand side. Add our like terms. Let's subtract 13 from both sides. Let's divide by 5. X equals 7. That's our solution. You can put it in the original problem and check it. When we multiply all terms on both sides of the equation by the least common multiple, the resulting equation might yield numbers that are not solutions of the original equation. These numbers are called extraneous solutions. Thus, we must check all possible solutions in the original equation. If you have carried out algebraic procedures correctly, you need only check to see whether or not a number makes the denominator 0 in the original equation. If it does make the denominator 0, it is not a solution. So let's look at this example problem. I want to state going into this problem that I sure hope that x is not equal to 0, because if it is, 2 over x will be undefined. Is there another value of x that you might have trouble with? What if x were 3? No, that won't work. It won't work in either 5 over x minus 3 or in 15 over x squared minus 3x. So I just want to state in the very beginning that x cannot be 3, it cannot be 0. I have a problem with both of those numbers, and I hope you do too. So let's clear the fractions here. We need to identify the least common multiple. Let's factor this. It's x minus 3. So our least common multiple needs an x, and it needs an x minus 3. So we're going to multiply both sides of this equation by x and x minus 3. That is the one thing that is guaranteed to cancel all the denominators out. Look at that right-hand side. We already know it equals 15. That is lovely. So let's use the distributive property on the left-hand side. So we have x times x minus 3 times 2 over x plus x times x minus 3 times 5 over x minus 3. So the x's will cancel, and you have 2x minus 6. The x minus 3's will cancel, and you have plus 5x equals 15. Go ahead and solve this. What's our next step? Do you add 6 to both sides? Divide by 7. X equals 3. Uh-oh. We started off this problem by saying x can't be 0, x can't be 3. That's just not allowed. 3 causes division by 0. We can't have division by 0. It's undefined. So even though we got this answer and even though we did everything right, it is extraneous. It's an extra answer that has no meaning in our problem. We have to disregard it, throw it out. So there is no solution. 3 is not a solution, and it's the only solution I see, so we're without hope here. There's no solution. Some problems just can't be worked. Let's try this one. So these both have the same denominator, so we're just going to multiply both sides by x minus 5. And when we do that, our denominators cancel, so we have x squared equals 25. One way to solve this is to subtract 25 from both sides. We have equals 0. It's a special product. So now, what is x? X equals 5 or negative 5. How do you feel about those solutions? Look back at the original problem. Is Are both of these solutions good solutions? Or is there a problem with one of them that causes division by 0? That 5 just won't work. It creates division by 0 in the original equation. So our solution is -5. Always check your answers. Look to see if they cause division by 0. So given that f of x equals x minus 15 over x, find all values of x for which f of x equals 2. Well, if f of x equals 2, then we're going to replace f of x with 2. What are we going to multiply both sides by? What does that give us? How do we solve this? We need equals 0. Now what? Can you factor it? What are the signs? 5 and 3. Where does the 5 go? So that gives us and we want to look back in the original problem. Are -3 and 5 valid answers? Yes, they're okay. Neither one causes division by 0. So those are our two solutions. And that's all for section 5.5.